morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. Now, in this video, we are continuing. We are still looking at Calculus 2, applications of differentiation. Now, this is example number 2, which reads, we are starting with question A. For what range of values of x is the function y is equal to x plus 1 over 4x increasing? That's question A. Then B, what are the coordinates of the stationary points? Okay, so to continue, what we are going to do is this. We are going to find the stationary points. That will help us to draw a graph, the sketch of this equation for that function, represented by that function, okay? And then that will help us to know where it is increasing. And upon us doing that, we have also found the coordinates of the stationary points. So we have y is equal to x plus 1 over 4x. Y is equal to x plus 4x to the power negative 1. We differentiate dy, x is equal to 1 minus 4 to the power negative, minus 4x to the power negative 2. Dy dx is equal to 1 minus 1 over 4 to the power 2. Then we will write a statement when dy dx is equal to 0, 1 minus 1 over 4x squared is equal to 0, 1 over 1 is equal to 1 over 4x squared. So I've taken 1 over 4x squared to the other side of the equation, then we cross multiply. It will be 4x squared is equal to 1, which you have done your working properly. Four x squared is equal to 1, we divide by 4, we divide by 4. 4 can go into itself 1, 4 can go into itself 1, x squared is equal to 1 over 4. We apply the square root plus or minus the square root on both sides, squared and the square root cancels out, x is equal to plus or minus 1 over 2. And then to find the y coordinate, we are going to say when x is equal to 1 over 2 in y. So y, okay, is equal to 1 over 2 plus 1 over 4 multiplied by 1 over 2. 2 can go into itself 1 into 4 is a 2. Therefore 1 over 2 plus a 1 over 1 over 2. A 1 over 1 over 2 is a complex fraction. So to simplify a complex fraction, you say 1 over 2 plus. You get the numerator here, okay? This is treated as one denominator. So you get the numerator there, which is a 1. You multiply by the reciprocal of this denominator, which I've circled down. Reciprocal 1 over 2 is just a 2. So it's the same as saying 1 times 2. So it's going to be 1 over 2 plus 2. 1 over 2 plus 2 is the same as saying 1 over 2 comma 2 remainder 1 over 2. So the same as 2 remainder 1 over 2, like that, or 5 over 2. And then after we have done that, we can also say, okay, when x is equal to negative 1 over 2 in y, y is equal to negative 1 over 2 plus 1 over 4 multiplied by negative 1 over 2, which is equal to a negative 1 over 2. 2 can go into itself, 1 into 4 it's a 2 plus, or it will be minus, because you're dividing a plus and a minus sign, it becomes a minus. Complex fraction, 1 divided by 1 over 2, so it's going to become negative 1 over 2 minus 1 multiplied by 2. Then it's going to become negative 1 over 2 minus 2. If you simplify it nicely, you are going to have a negative 5 over 2, which is the same as writing a negative 2 remainder 1 over 2. So it means you have a negative 1 over 2 comma negative 2 remainder 1 over 2, like that. I hope what I'm saying is clear. Yes, so we clean up. I hope you even know how to differentiate. There are many videos on how to find the derivative. If you don't know up to now, you are going to struggle. So those are the two coordinates that you have. You draw your x or y plane like that. That's the y-axis, that's the x-axis. And then our stationary points, the first one is half, comma, 2 halves. So half can be somewhere there, 2 halves can be somewhere there, and then we have your 0 there, and then you have your negative half there, and then you have your negative 2 halves can be somewhere there. So if we were to plot this, it would give us something somewhere here, and then for this one somewhere there. Okay, so if you look at what I've done, I have drawn 2 points. I have plotted 2 points right there. This half comma 2 remainder 1 over 2 and negative half comma negative 2 remainder 1 over 2. I've plotted them. Now we need to sketch them. Sketching these graphs involves you knowing properties of the x or y plane or the number line. We can also say properties of the number line, but let's say of the x or y plane, it's much better. If you look at it very well, the turning point of this particular function is this one and that one. So those are the turning points. Now, how will you know that this turning point is like this or that turning point is like this? How will you know how it's supposed to be drawn? Quite simple, actually. Quite simple. Just do this. For example, you have substitute positive 1 into this function here. Y is equal to whatever. You are going to have 5 over 4. So you're going to have a 1, 5 over 4. And 5 over 4 is actually a larger number than half. Right? Okay. So try to substitute a positive 2. If you substitute a positive 2, you're going to have 2 plus a 1 over 8. So you're going to say 8 times that is 16 over 8 plus 1 over 8. It's going to give you 17 over 8, which is you can say 2 remainder 1 over 8. So you have a 2 remainder 1 over 8. Okay? That is when you substitute a. So you say y is equal to 2 remainder 1 over 8 when x is equal to a positive 2. Take note. I want you to take note of something happening here. The x coordinates are increasing, right? Then, if you look at the y coordinates, okay? If you look at them nicely, and you try to notice a pattern, you will see that the y coordinates are reducing. Try to substitute a 5 here. Now I'm going to use a calculator. So it's going to be a 5 plus a 1 over a 5 plus a 1 over 4 multiplied by a 5. You're going to have a 6 remainder 1 over 4 as your y. Okay? So, what I want you to do is pay attention to the x coordinates. Okay? It's like the x coordinates are decreasing in value until it reaches half, and then they start increasing in value again. I don't know if that's making sense. Is it? So you have tried substituting even let us say if you substitute a 5, let's substitute a 6. We'll say 6 plus a 1 over 4 multiplied by a 6. I'm going to have 6 point something. Okay? which signifies that this side, as you are going from the highest point, that side, wherever the curve is going, it's increasing and to infinity, it's just increasing, but the x values are reducing. It also means that the y values are increasing. That's what I want you to look at. And then if you check this other stationary point here, so I wanted just you to understand there, that's why I was answering very fast so that I can give a long explanation. Okay, so if you check here, if you substitute a -1, you're going to have a -5/4, which means that it is slowly increasing. The values of x are increasing until they start decreasing again. Okay? The function starts decreasing again. Increasing and decreasing functions. So until the value of y starts decreasing again. So it was increasing as it was going up, then the values of y starts decreasing. So if you want to know if it's increasing or decreasing, look at the values of y. This side, the value of y is increasing. And then this side, the value of y is increasing. But it reaches a point where the value of y will give you a stationary point. Then even here, the values of y are increasing. Then here, they'll start decreasing once again. I don't know if that makes sense. I hope it makes sense. Okay? Think of it like that. Therefore, to know where the curve is increasing, I said it's standing at somewhere half, -half is somewhere there. So where is it increasing? You will say x is less than -half, comma, here it is increasing also this side. So you will say x is greater than +half. Then the coordinates of the stationary points is what we found. It is here, this same point there, half, comma, 2 and a half, I mean. And then we have half, comma, -half, comma, -2 halves. 2 and a half, sorry, like that. So that's it for this video. Thank you so much for watching. This has been Cornelius Lubinda with another video, and